In the vast, uncharted frontier of our solar system, there exists a frozen world that has captivated the curiosity of scientists and dreamers alike. It is a place where the impossible might just be possible, a moon that orbits the giant planet Jupiter, known as Europa. Imagine, if you will, a world encased in ice, where beneath its frozen surface lies a vast ocean, an ocean that could harbor the building blocks of life. As we stand on the cusp of the 2024 Europa missions, we find ourselves closer than ever to answering one of humanity's most profound questions. Are we alone in the universe? The stakes are high, and the answers could redefine our place in the cosmos. Europa is more than just a moon. It's a tantalizing mystery that has intrigued scientists for decades. Unlike Earth, Europa's surface is a harsh, icy desert. But beneath this seemingly lifeless exterior lies an ocean of liquid water, potentially teeming with life. This ocean is not a shallow pond, but a vast, dark abyss that could be more than 100 kilometers deep, containing twice the volume of all Earth's oceans combined. The idea that life could exist in such an alien environment is thrilling, but for life as we know it to thrive, certain conditions must be met. And one of the most critical of these conditions is the presence of oxygen. In the next few years, NASA's Europa Clipper mission aims to explore this possibility in unprecedented detail. So, is there oxygen on Europa? Oxygen is essential for most known life on Earth, fueling the processes that convert nutrients into energy. If oxygen is present in Europa's subsurface ocean, it could indicate the potential for complex life forms. However, Europa's ice shell, which may be up to 20 kilometers thick, poses a significant challenge. On Earth, oxygen is produced by photosynthesis, but on Europa, it likely forms through radiolysis, a process where Jupiter's radiation breaks down water molecules in the ice into oxygen and hydrogen, with the oxygen getting trapped in the ice. The big question is whether this oxygen can reach the ocean below. Scientists suggest several mechanisms. The ice shell might have varying layers, with thinner, more dynamic sections, allowing oxygen to mix with the ocean, or convection currents could transport oxygen-rich ice downward. Tidal forces from Jupiter's gravity could also create cracks in the ice, enabling oxygen to seep through. If oxygen reaches Europa's ocean, it could potentially support life, perhaps similar to extremophiles on Earth that thrive in extreme conditions like deep-sea vents or subglacial lakes. While this remains speculative, the Europa Clipper mission aims to explore these possibilities in unprecedented detail, potentially bringing us closer to discovering extraterrestrial life. The Europa Clipper mission. The Europa Clipper mission represents one of the most ambitious projects in the history of planetary exploration. Slated for launch in 2024, the spacecraft will embark on a journey to the outer solar system where it will conduct a series of close flybys of Europa, each one bringing us closer to understanding this enigmatic world. The Europa Clipper is equipped with a suite of cutting-edge instruments, each designed to probe different aspects of Europa's icy surface and hidden ocean. One of the primary objectives of the mission is to measure the thickness of Europa's ice shell and search for subsurface lakes or other liquid water reservoirs that might lie closer to the surface. These subsurface lakes could be key sites for the mixing of surface oxygen with the ocean below. The spacecraft's radar system, known as REASON, Radar for Europa Assessment and Sounding, Ocean to Near Surface, will play a crucial role in mapping the structure of Europa's ice shell. By sending radar waves through the ice, REASON can detect variations in its thickness and composition, revealing areas where the ice might be thinner or where liquid water could be present. This data will help scientists identify potential pathways for oxygen to reach the ocean. Another important instrument on the Europa Clipper is the MICE, Mapping Imaging Spectrometer for Europa, which will analyze the composition of Europa's surface in detail. Mice can detect a wide range of materials, including salts, organics, and water ice, providing clues about the chemical processes occurring on the Moon. If oxygen is present on the surface, mice could help identify its distribution and concentration. The Europa Clipper will also search for signs of water vapor plumes that might be erupting from the Moon's surface. These plumes, if they exist, could provide a direct link between the ocean and the surface, allowing oxygen and other materials to mix. In addition to searching for oxygen, the Europa Clipper mission will look for other potential signs of life, such as organic molecules. These molecules are the building blocks of life and could provide evidence that Europa's ocean has the necessary ingredients for life to emerge. The spacecraft's mass spectrometer, MASSPEX, Mass Spectrometer for Planetary Exploration, will analyze the chemical composition of Europa's atmosphere and surface, searching for complex organic compounds that might indicate biological activity. As the Europa Clipper collects data during its flybys, it will transmit the information back to Earth, where scientists will begin the painstaking process of analyzing the results. This mission is expected to revolutionize our understanding of Europa and could provide the first concrete evidence that life might exist beyond Earth. But the Europa Clipper is not the only mission that has set its sights on this intriguing moon. The Galileo Orbiter mission. Before the Europa Clipper, there was Galileo, a mission that paved the way for our current understanding of Jupiter and its moons. Launched in 1989, the Galileo spacecraft spent over 8 years orbiting Jupiter, providing a wealth of data that has shaped our knowledge of the Jovian system. Galileo's encounters with Europa were among the most significant moments of the mission. During its flybys, the spacecraft captured detailed images of Europa's surface, revealing a world unlike any other. The surface was found to be covered in a layer of water ice, but it was not smooth or featureless. Instead, it was a complex and fractured landscape, crisscrossed with ridges, cracks, and chaotic terrain. These features suggested that Europa's ice shell was dynamic, constantly being reshaped by forces from within. One of Galileo's most important discoveries was the detection of a weak magnetic field around Europa. This magnetic field was puzzling, as Europa itself is too small to generate a magnetic field like Earth's. The most plausible explanation was that the magnetic field was induced by Jupiter's powerful magnetosphere, interacting with a conductive layer beneath Europa's surface. The best candidate for this conductive layer was a salty ocean, a finding that provided the first strong evidence that Europa's ocean was not just a theoretical possibility, but a real, physical entity. Galileo's data also hinted at the presence of subsurface lakes or regions where the ice shell might be thinner. These areas could be potential sites for the exchange of materials between the surface and the ocean, making them prime targets for future exploration. However, while Galileo provided tantalizing hints about Europa's potential habitability, it was not equipped with the instruments needed to explore the Moon in detail. The spacecraft's instruments were designed for general reconnaissance, not the in-depth analysis required to search for signs of life. This limitation has left many questions unanswered, questions that the Europa Clipper mission is specifically designed to address. As we prepare for the launch of the Europa Clipper mission, we stand on the threshold of a new era in the exploration of our solar system. The 2024 Europa missions represent humanity's most concerted effort yet to answer one of the greatest questions of our time. Are we alone in the universe? Europa, with its hidden ocean and the potential for life, is one of the most promising places to search for an answer. The Europa Clipper mission, building on the legacy of the Galileo orbiter, will soon embark on a journey that could change our understanding of life beyond Earth forever. But the search for life on Europa is more than just a quest to find aliens. It's a journey of discovery that could reshape our understanding of the conditions necessary for life to emerge. By studying Europa, we're not just exploring a distant moon, we're learning more about the processes that shaped our own planet and the potential for life to exist elsewhere in the cosmos. So what do you think? Will the Europa Clipper mission find evidence of life on Europa? Or will the search for extraterrestrial life take us even further into the depths of space? Share your thoughts in the comments below, and if you enjoyed this video, don't forget to like, subscribe, and hit that notification bell so you never miss an update on the latest discoveries in space exploration. The universe is vast, and the search for life is just beginning. Stay tuned for more exciting developments as we continue to explore the final frontier.